Okay, hello everyone. This is the third part of our lesson, that is integer chapter. Here we will going to learn what are the properties of addition, multiplication, subtraction and division, that is commutative property, closure property, associative property, distributive property and some more properties of addition, multiplication and the division. Okay, so let's start. Okay, so now we will start with the properties of addition, subtraction, multiplication and division. That is, what are the different properties related with the addition of the integer, subtraction of integer, multiplication of integer and the division of integer. So our first property is the closure property. So first we have to know what is our closure property. So in closure property it says that if we will take two or more integer, let us take two integers. So if we will take two integer and we will do the operation, any one of the operation, either addition, subtraction, multiplication or division, then we should get the integer as well. Okay, so for the addition, let us take suppose we are taking 3 and then 4. Okay, so I have taken one integer 3, I have taken one integer 4 and the operation is addition. So with 4 plus 3 is 7. So see here, 3 is an integer, 4 is an integer, and after doing the operation we got a integer itself, that is 7 is also its integer. So yes, for the addition the closure property is true. Now we will see for subtraction. So let us take 5 then minus 2. Okay, so see here, 5 is an integer, 2 is an integer, our operation is subtraction. Okay, and what answer we will get? We will get the answer as 3. So I have taken an integer here, I have taken an integer here, I have done the operation of subtraction, I got an integer. So for subtraction also closure property is true. Now we will go for the multiplication. So we will take 12 into 6. Okay, so here I have taken, let us take minus 12 into 6. So here I have taken one negative integer minus 12, I have taken one positive integer plus 6, I have done the operation of multiplication. Now I am getting over here minus 72. I have taken an integer, here also I have taken an integer, I have done the operation of multiplication, I got a integer. Okay, now lastly we will see for the division. So if I will take 4 by 2, so 4 divided by 2, 4 is an integer, 2 is an integer, I got an integer. But in case of 0 divided by 3, now we already know if any integer, if 0 is divided by any integer, then the answer is 0 itself. But if we will do the reverse of it, that is 3 divided by 0, here any integer being divided by 0, this possibility is not, this is not possible. Okay, so for this kind of division we are writing not defined. So here I have taken one integer 3, I have taken one integer 0 and I have done the operation of division, but I did not got any integer over here, rather we got such a number which is not defined. So for addition closure property is true, for subtraction closure property is true, for multiplication closure property is true, but for the division our closure property is not true. That is, when we are taking an integer we are doing the operation of division but we are not getting an integer. So for division our closure property is not true. Now let us see our next one, that is commutative property. Okay, so now we will start with the commutative property of addition, subtraction, multiplication and division. So for the commutative property we have to know that commutative property means if we will change the order of the integer and then we will perform the operation the result will remain the same. If it is same, then yes, commutative property is true. If it is not same, then that for that particular operation the commutative property doesn't hold true. So let us start with addition. If we will take 6 plus 3, we will get 9. Now if we will change the order, okay, now 3 we will write first, 6 we will write second. So 3 plus 6, then also we will get 9. So for addition, commutative property is true and we will write yes. Now let us see for the subtraction. In the case of subtraction, suppose we take 5 minus 4, we will get over here 1. Now if we will change the order, that is 4 minus 5, we will get minus 1. So here you can see that when we have changed the order of the integer, that is when we have written the 4 at the first and 5 at the second, the answer is changed. Okay, so for that our commutative property for subtraction is not true. So we will write here no. In the case of multiplication, now let us see for the multiplication. 6 into 5 will get 30. Now let us change the order. 5 into 6, then also we will get a 30. So for multiplication we will change the order. Okay, we have to take two integers. Okay, always we have to take two integers, we have to perform the operation. So 5 into 6 or 6 into 5, we got the same answer. So for multiplication our commutative property is true. Now lastly we will see for the division. 8 divided by 4, we got 2. Now when we will change the order, that is 4 divided by 8, we will get 1 by 2, that is 0.5. So you can see here that our answers are not same. Okay, when we have changed the numerator with the denominator, interchange the numerator and denominator, the answers are not same. So for division our commutative property is not true. So our commutative property is hold true only for addition and multiplication, doesn't hold true for subtraction and division. So after commutative property we will go for the associative property. So in the case of associative property, it is same like commutative property, that we have to interchange the integers, but here we have to take three integers and then we have to perform the operation. Like for example, here I have taken three integers, 3, 6 and 2, and the operation is addition. So first I have taken 6 and 2. So 6 plus 2 is 8, then 8 plus 3 is 11. Now I will interchange the order of addition, that is first I will add 3 and 6. So 6 plus 3, I have taken 9. Then I will add with 2. So 2. So I got the same answer. So for addition, associative property is true. Now we will go for the subtraction. In the case of subtraction, I have taken three integers, 4, 6 and 2. First I will subtract 6 and 2. I got 4. So 4 minus 4 will be 0. Now in the next step, I will take 6 and 4 together. So 4 minus 6, I got minus 2. And then I will subtract it with minus 2. So minus 2, I got the answer minus 4. So in first case, I got 0. In second case, I got, that is when I've interchanged the integer, I got minus 4. The answers are not same. So the associative property for the subtraction, it is not hold true. Okay, that we cannot interchange the integers. Now in the case of multiplication, I have taken the integer 5, 2 and 3. So first I will multiply 2 and 3. So 3 into 2 I got 6, and then I multiplied with 5. So 6 5 is 30. Now in the next step, I will first multiply 5 and 2. That is, I will interchange the order of multiplication. So 5 into 2, 10. And then I will multiply it by the last integer, that is 3. I got 30. The answers are same. So for multiplication, our associative property is true. And lastly, for the division, I take 4, 8 and 4 as the integer. First I will divide 8 and 4. I got 2. And then when the 4 is divided by 2, I got the answer 2. Second step, I take first division of 4 and 8. So 4 divided by 8, I got 0.5. Then I will divide it with again the last integer, that is 4. I got 0.125. So you can see here in first case I got the answer as 2. In second case I got the answer as 0.125. So both the answers are not same. So for division, associative property is not true. Okay. So in the case of associative property, we have to take, in commutative property we take in 2 integer and perform the operation, whether subtraction, whether multiplication. Here we have to take 3 integer. First we have to group any 2, then perform the operation with the third one. Okay, so here we have to take 3 integer, then we have to perform the operation by interchanging the places of the integer. Okay, and if the answers are same, the property holds true. If it is not same, property doesn't hold true. Okay, so now we have distributive property of multiplication. So in case of distributive property of multiplication, it is over addition or over subtraction. As the name says, distributive property, distribute. So it means that it will distribute the addition or it will distribute the subtraction, and it is over the property of the multiplication. So let us see over the addition how it look like. So for over addition, let us take 2 into 3 plus 4. Now see, it is outside the bracket, it is a multiplication. Inside the bracket, it is a addition. So this is known as your distributive property over addition. Now for the subtraction, 4 into 6 minus 2. So outside the bracket it is multiplication, inside the bracket it is subtraction. So this is distributive property of multiplication over subtraction. Now how we will solve? So whenever such kind of expression is there, the bracket, inside the bracket, the integers, they will distribute over the multiplication, and the sign, the operation will be of addition, like 2 into 3. First we will write, then addition, then 2 into 4. It means that this 2 will multiply with 3, this 2 will multiply with 4, and in between them the operation will be addition. This is known as distributing. This distribution of the integers will take place over with the multiplication. So 6 plus 8, we got 14. Okay. Now similarly here, 4 into 6 and then minus 4 into 2. This multiplication will distribute over the subtraction. That is, 4 will multiply with 6. Then whatever operation is there in the bracket, that is minus, then 4 will multiply with 2. Now 6 into 4 is 32. 4 into 2 is 8. So we will get 24. Okay, so this is known as our distributive property of multiplication. Over addition will look like this, over subtraction will look like this. So here we have some more properties of the addition, that is additive identity and additive inverse. So first we will see what is additive identity property of addition. In additive identity, whenever a number, an integer, being added to such a integer so that the answer will remain the same, that is known as the additive identity or identity element. Okay, like for example, if I am provided with the integer 2 plus what we will add here so that we will get the same answer. So we already know that any number being, any integer being added with 0, we get the same integer. So here 0 is known as the additive, this property is known as the additive identity property of addition, and 0 is known as the identity element. Okay, so additive identity means an integer being added with such an integer so that the answer should remain the same. Okay, so for all the cases, suppose if the question came, what is the identity element for 3? So it will be 0, because when I will add 0 over here, I will get the same answer. Okay, so for any integer, suppose for minus 4, what is the identity element? Again it will be 0, because when I will add 0 with minus 4, I'll get the same answer. So for all the integers, the identity element will be 0, and this property is known as the additive identity. Now for the additive inverse, an integer being added with the another integer so that the answer will be 0. Okay, so 5, what I will add here so that my answer will be 0. So we know that for this we have to just write the same integer with the opposite sign. The sign of the integer 5 over here is plus, so the sign of the integer will be minus 5 over here so that the answer will be 0. So in this property is known as the additive inverse, that is an integer being added with another integer such that the answer will remain the 0. So what will be the additive inverse of minus 16? The additive inverse of minus 16 will be the same integer with the opposite sign, that is plus 16. Okay, what will be the additive inverse of minus 6? It will be plus 6. What is the additive inverse of 4? The additive inverse of 4 will be same integer with the opposite sign. Okay, so that whenever we will do the addition, the answer will be 0. This is known as the additive inverse property, and this integer is known as the additive inverse of the another integer. Okay, so for the multiplication we have multiplicative inverse and multiplicative identity and property of 0. Now multiplicative inverse, with a given integer we have one more integer such that when these two integers are being multiplied we will get the answer as 1. So if the given integer is 2, we will multiply with that integer the reverse of this 2, that is 1 by 2. Okay, then when we will multiply both, we will get the answer 1. Similarly, 4 minus 3, we will multiply in reverse of it, that is 1 by minus 3, so that our answer is 1. And for 1 by 4, we will multiply with the reverse of it, that is 4 by 1, that is 4, so that our answer is 1. That is known as your multiplicative inverse. So multiplicative inverse of 2 will be 1 by 2, minus 3 will be 1 by minus 3, and 1 by 4 will be 4. If I will ask what is the multiplicative inverse of 6, then multiplicative inverse of 6 will be reverse of it, that is 1 by 6, so that our answer is 1. Similarly, we have multiplicative identity. With the given integer, we will multiply such an integer so that our answer will remain the same. So there is only one such integer, which is your 1. So that whenever we will multiply with the given integer with 1, our answer will be same. That is, if I will multiply with minus 6 into 1, it will be minus 6 only. So this is known as your multiplicative identity or identity element for multiplication. Okay, 1. That is, multiplicative identity means I will multiply with the given integer such an integer so that our answer will remain the same. So here is only one integer, that is your 1 is only there, which is multiply. Whenever multiply with the given integer, the answer will remain the same. And lastly, property of 0. Property of 0 means whenever any integer is being multiplied with 0, we will get the answer as a 0. Okay, with the 0 we don't have to write any plus or minus sign, just 0. Okay, suppose we multiply minus 10 with 0, we will get 0 only. Okay, this is known as the property of 0. Okay, now for the division we have the first property is for the division is 0 divided by any integer. The answer, that is the question, will always be 0. Whether you take positive integer, you take negative integer, that is 0 divided by minus 10. If you will take, the question will always be 0. Okay, we don't have to put any plus or minus sign in front of the 0. Now the second property of the division is that any integer being divided by 0, such numbers are not defined. So we will just write not defined. Okay. Similarly, if minus 12, or let us take 15. Okay, 15 divided by 0, that is any integer being divided by 0, such numbers are not defined. Okay.